Hi, I'm Colin Walls and I'm here again to talk about embedded software. Today I want to consider the subject of passing parameters in the C language. Now, most of what I have to say is actually applicable to any programming language, but because broadly speaking, when you're writing a piece of code, you'll want to process it some data and you've got to get that data in there somehow. So passing parameters to a function is a typical approach to doing that. Now you have most control, of course, when you're writing assembly language. In assembly language, you have essentially 4 ways you can pass data into a subroutine. One would be to simply use global variables. So assign a number of variables which are accessible across your entire software and use those to pass data. And that's quite acceptable. You end up with non-reentrant code and so forth, but it's quite straightforward. Another way, which is faster and not uncommon, is to use registers. Now, depending how many registers your processor has got, this may or may not be ideal, but if you've got plenty of registers, maybe that would be a good way of passing parameters because they can be accessed very quickly. And many processors have instructions that let you access registers in a straightforward way. Another possibility is the stack. The stack gives you an indefinite amount of storage which can be used very flexibly, and on modern high-end processors, accessing the stack is quite flexible and efficient. So that's quite a good choice. And lastly, you could use a block of memory which is used for passing parameters where you can enter the data in different ways depending on what function you're calling. Just like using global variables, this has a reentrancy issue, so if you need code to be used in a multi-threading environment of some kind, then this is not a good approach to take without enormous care. So those are the options when it comes to passing parameters when you're writing assembly language. Now if you're writing C, you don't have so much choice. In fact, you probably have no choice at all because the compiler will do the work for you and it will do it in the way that it wants to do it. In fact, the C language standard says very little about how parameters need to be passed. It basically gives an idea about aspects of the parameters, but leaves the details up to the compiler. This leads to some interesting conclusions. Now, typically, a compiler will pass parameters on the stack, and we could do things like this code. This code accesses the stack explicitly, and then indexes off of that location to pick up the parameters. I have a request. Please don't do this. It's not a good way to write code. It's compiler dependent, it's certainly CPU dependent, it's dependent on everything really. It's just not portable code in any way, or shape or form. So please don't do it. It's just an interesting way to understand the mechanism, something to play with, but writing real code this way is not smart. Now the C language passes data by value. It means that when you pass a parameter into a function, the value of that parameter is copied into the inbound variable, however that's stored, so on the stack as we have said. So changing that value inside the function doesn't do anything. It just changes the copy that you've got, and that's common practice. It's not unreasonable to mess with that value if it suits you. If you want to influence something in the calling program other than returning data, you need to have the calling program pass you pointers to the locations you need to change. And that's quite straightforward, just a bit more complex, and pointers are a little bit more hard work to do. The C++ language makes that simpler. The plus point is by using passing by reference parameters, you can access the variables in the calling program without messing with pointers. Basically, the compiler doesn't work for you. The drawback is when you look at a call to the function, you can't see that they're reference parameters unless you carefully study the prototype. So it can lead to less readable code. And at the end of the day, readable code is what it's all about. Writing code that people can understand is the priority. So personally, I would stick with passing by value, pass a pointer when you need to, as explicit code, and just be careful because pointers are hard work. So most of the time you don't need to know how parameter passing works, but embedded developers like to know what's going on inside their code, even if they can't really change it. But it gives them the option of making code more efficient as and when that's necessary. So that's all for today. I'll be back again soon with another embedded software topic. Until then, bye for now.